Hello, everybody. My name is Zach Hansen from Iowa State University, and I'm here to talk to you today about complex adaptive systems within airport systems. So, what we currently have within airlines and airport systems is a top-down infrastructure where essentially flights are assigned based on what we think is best and the price that we think is best. Um, that's not really working out. They're overbooking flights, people are unsatisfied, and airlines are losing money. And I want to try to tackle this issue on all ends of the project. And we're doing this through complex adaptive systems. So, the way we do this is through bottom up infrastructure, where the people, rather than being the end product, are the start of the process. So, this happens when people put in their parameters of where they want to leave from, where they want to land, what day, what time, and they have a price point in their mind when they're going through this. So once they input this information, they're then entered into a queue where they are held until the flight that they want to be on reaches a minimum viability. Minimum viability in this case would be where the airplane has enough people on it to make money. So if we take an ERJ 135, for example, with a maximum capacity of 37, the minimum viability may be somewhere around 27 people. So once that 27 people is reached, they would then have a flight. They would be booked on a flight, and they would 100% be able to get on that flight. Um, After that point, the airplane essentially is wanting to fill its flights so that way it can make more profit, the people in the green. These are the minimum viability people in the black, where that are already booked. So it's essentially trying to fill the rest of the seats, which is again all profit. So it does this by sending a signal back to people saying, "Hey, we have more seats. We can discount these for you to get you on them." So in that way, it's cheaper for the people as well. Um, Once this flight is booked up, and say, one more person books the flight, so 38 people, it would then just bump it up to the next size of plane, and then that plane would attempt to fill the seats with a discounted rate, and so on and so forth, until we reach an Airbus, a double-decker Airbus, um, which is definitely going to be profitable. Um, After we reach this amount of people and the planes are satisfied, so to speak, we then look at the third agent, which is the airports. So the airports need circulation in order to make a profit, and they also need to be functional. And in that way, they need a maximum amount of airplanes. So that way they're not bogged down and they can keep running smoothly within their own network. So we can give the airports, say, a minimum viability of 1/2 terminals filled and a maximum viability of 1 1/4, so they can keep turning them out. Once this is uh, thought through, the airplanes are then sent a signal from the airport saying, "Hey, we have too little planes. We need you to redirect flights here." Airplanes then communicate to the people saying, "Hey, would you like to take this route? We can give it to you for cheaper as an incentive, or we can give it to you at this time rather than the time that you may have not gotten," which would also provide an incentive to the people. Just changing that parameter in some way to make the people want to take that flight. And the same thing essentially would happen if the airport is too full. It would just direct flights away and have the same communication to the planes and the people. After all of that system is taken care of, something we may see are emerging routes and emerging nodes. So rather than predetermining that Denver is going to be a main hub where everybody's going to fly in to and get distributed out of to connecting flights, we may see things like Chicago being a main hub for people, um, because that's where they want to fly out of, or that's where they want to go to. Um, Not saying that's what's going to happen, but it is a possibility. Another thing we may see is smaller airports that are exclusive to one airport. Say, take Waterloo, Iowa, which flies exclusively to Chicago O'Hare, may then, rather than just doing that, also offer other flights that are in demand from the people. It may not. I'm not to say, only the system would be. Um, so with those emerging routes and these three agents, something else we would see would be the price decline of the ticket. With the three agents, what we can see here is that we have kind of a stagnated price until the plane reaches its minimum viability, at which point the ticket begins to fall in price until we're reaching the larger planes with the lower ticket prices. Again, uh, the price is subject to fluctuate based on plane size, fuel cost, and what have you. But overall, it's going to be better for the people because it's going to be more of a distributed cost rather than a supply and demand cost. And the airlines are going to continue to make their money, which is good on both ends. So in conclusion, these three systems are going to take the whole airport system and turn it on its head and make it more profitable, more efficient, and more satisfactory to its clients. Um, with the system, too, all of these agents are going to be reaching their goals, which, as stated earlier, is going to increase profits. Um, and by using this complex adaptive systems model, airlines are essentially going to reinvent the way that we fly, and it's going to be better on all ends. Uh, the collaborators on this project were myself, Zachary M. Hansen, Sharon Wool, and Iowa State University, and our contacts are at the bottom of the screen there. Thank you very much.